So welcome to the new video. Today's question is minimum window substring. Given a two substring S and T of lengths M and N respectively, return the minimum window substring of S such that every character in T, including duplicates, is included in the window. If there is no such substring, return the empty string. The test case will be generated such that the answer is unique. Suppose this is the substring, this is a two string, these are two string S and T, and we have to find ABC. ABC should be contained in the substring. The substring should contain ABC. It can be in any order, but it should be ABC. The complete T should be present in that substring. Suppose we are taking and we have to find the minimum window. So BA and C is such an example where ABC is there. And similarly, if T is A, then it is present in A, S. If you select because S is A and T is AA, so it is not present, it is empty. So we do not get any substring. So you have to return the minimum window. So what could be the brute force of this? So first of all, let's take an example. Wait a minute. Yeah. So actually this, yes, what is example? ADOBE and COD EB A and C. This is the substring. This is a string, and we have to find T equals to ABC in it. So our answer is B, A, and C. How we will reach to the answer? Let's apply brute force first by generating all the substrings. First of all, let's generate this substring ABC. So if we will consider this substring C, it is containing ABC. Similarly, we will reach somewhere here also, but we have to find the minimum length. So we will calculate min length also, minimum length, and also starting index, because we have to return the substring. Minimum window, we have to return the substring. So for returning substring, we can use a substr function of C++, s dot substr. We will write start index here, and then we can write length, minimum length. So we will get the substring. Okay, start index is initially -1 and minimum length is 0 initially. We will make a map for checking that A is there in the substring or not, B is there in the substring or not, C is there in the substring or not. So first let's traverse the T and put in the map. So A,1, B,1, character and frequency is stored in map. Okay, so map has A, B and C. Now let's move. First of all, I is here and J is also here. Then J moves, and we reduce, and we were at A first, so we found the A. Also we will make a count. Okay. So A changes because we found A and A was in the map. A is positive. Suppose we found any character which is positive. A is having 1 which is greater than 0. So we will reduce it to 0 because we have used it, and we'll increase the count to 1. Okay. Now J moves to D. Now D is not in the map, so we will put it as -1, because 1 indicates that we have traversed T and put in the map. That means it is pre-inserted. It is already existing in the map. Okay. But D does not exist. That's why we put it as -1. So now we move to O. O also does not exist, we will put it as -1. B exists as 1. It is greater than 0, so we will reduce it to 0 and increase our count to 2. When it is positive, when we found a letter which is positive, then we will increase the count. And if our because length of t is 3, if our count is equals to m, this means we found the substring, we found t in our substring, so we will update the max length, min length. Okay, this is the concept. Now we move to E, put E in as -1. Similarly, put O, put C as C, we found C, so we will decrease it to 0 and we will increase the count to 3. Now we found the count 3, so we will update the min length to, what is the min length? J minus I plus 1, minimum of this. So which is, we are on this 0, 1, 2, 3, 4, 5. 5 minus 0 plus 1 equals to 6. It is not the minimum, I think. When we found this 6th minimum length, so we will break this loop, because if we will increase further, then length will increase, not decrease. So it is not necessary to traverse the whole ahead length of substring string, because it will only increase we have to find minimum. So we just break it and we start from here. Now we will increase the I from here and J also from here. Okay, we will clear the map again, make the map again. We will make the map again. Also this stored as this, and update the starting index also. When we found the minimum, we update the starting index also. Starting index is now 0 and minimum length was 6. Now when we update the map, we clear the map, when we break the loop and increase the I, then all things will reinitialize. All the things will reinitialize. I from here, J from here. Okay. Now map also will be reinitialized to A, B, and C. Now move again. I is here, J is here. D, put D as -1. O, put O as -1. B, we found the E, increase the count to 1 and decrease the B, decrease the B to 0. And E is not there, so -1. C is there, so 0 and increase the count. O not there, D not there, put D not there. E not there, E also not there. B, it is there, it is also not there, so decrease it to -1. A not there, A is there, A is positive, so increase the count. Now count is 3, so max length become see 6, 7, 8, 9, 10. 10 minus 1 is 9, 9 plus 1, 10. Minimum length, no, it will not update. So this is how brute force will work. Let's write its code and see it is coming or not. So we will make a minimum length, which is suppose 1E9, and int start index equals to -1 actually, for int I equals to 0 to I less than s dot size I plus plus. Now we will initialize the count. Int count equals to 0. We'll initialize the map. Int map, it is map int char comma int, or we can make a hash also, or we can make a hash will be good, I think. It is even better. Int hash 256 size array, initialize it with initialize it with, yes, we will initialize it with 0, suppose. Now we will update the hash with t. T substring has ABC. We will update it with update the map with this. We'll increase the we'll put in the hash. Suppose it is k equals to 0 to k less than t dot size k plus plus. Update the hash of t k plus plus. Okay, now we have initialized everything, I think. Now we'll start the next loop for substring. J is less than I, j s dot size plus j plus plus, j plus plus. Now if decrement everything in the hash s of j, decrement it, just decrement. If we find count equals to suppose you found hash of any character greater than 0, then you will increase the count. Also, you have to decrement every time, and if count equals to m or k dot size, we will, what we have to do, see, have to update the min length and start index. So min length equals to minimum of min length comma j minus I plus 1 started index updates to I. Break the loop. Okay, so this is there, this is done, I think. Hash is greater than, okay, this is the substrings. I think we have found the, we have to print the minimum length substring now. So minimum length substring is return if s not equal, if s equals to -1, if starting index equals to -1, then return empty, or else return, we have to return s dot substr function. We have to return from start index till the minimum length, till the min length. I hope you understood this function. Yeah, I think this should run. K dot size, t dot size. Yeah, it is running exactly fine, but it will not submitted because it will not be submitted because the time complexity is 10^5. So actually it is wrong answer. Wait a minute. So there was a bug in our code which is about starting index. We are updating starting index every time when count equals to t dot size, but we have to update only when our minimum length changes. Okay, because we have to return the minimum window. So I think the answer should be in the, we will have the if condition, not through this function. If min len is greater than c- j minus I plus 1. So we will update the min now. Min to j minus I plus 1. Also starting index now. We will update the starting index also. Let's use this test case and now run the code. I think it should work now. Yeah. Now TLE should happen. Yes, TLE. Okay, so only 3 test cases are remaining. Now we will use the sliding window solution because it is window. It is written window. Now what was sliding window? Let's write the test case again. Okay. Let's write the test case again. We will select this and let's select this. Let's move down this example. Yes, I think it's great here. Yes, let's start. Here is this. Now let's start running the code, running the dry run 11 12. So this was our string and t was abc. Now what we have to do, we will use the map case only, but we will use 2 pointer now. Map was this, put like this, L and R, mainland, start index, and count. 3 things we have. Let's move. First of all, we will fill the hash map with A1 B1 C1 with this. Then we will start. We'll see our count, because hash of A is 1, so we'll reduce the 1 to 0 and we'll increase the count to 1, because whenever hash of R is positive greater than 0, then hash of S of R is greater than 0, we will update the count. Okay, we'll update the count, because this means we have our character in T. In this window we have the character in T also, so this is a valid window, so we'll increase the count. So now we will move R, because count is 1 only. So D is not there, so we will put it with -1. Now O is also not there, so put it with -1. B is there. Reduce to 0 and increase the count to 2. Okay, E is not there. Now C is there, so now see, count is 3. So min becomes, what is the min? Min is 5 minus 0 plus 1, which is 6, and starting index is 0, but we have to update. We have to find the minimum, so we will try to reduce by L. See, L moves here, but now what happened? A again inserted, because now A is not there in this substring. We have window which we have selected is not in the window, but it should be in the map because it is pre-inserted and we have to take it in our window. But when we move L, so L count, A count increases in the map, A frequency increases in the map, but it became outside, it gone outside of our window, so our window becomes invalid, and so count reduces to 2, because A is not in the window, so count is not equals to 3, which was our length of this T. Okay, So again you will move R. Now see, O is also not there, so it will be decrease. D also not there, and the E also not there. Now B. Now B also become -1, but count will not increase. A. Now we found A, but increase the count to 3. But see the length. See the length. It is from here to here. The window length is very big. 10 minus 1 plus 1. Yani, means 10. Which is bad. So we will not update. We will keep it 6 only. Now we have to move our left pointer. Anyhow we have to move the left pointer because it is very big window. So let's check. L moves to 0 and D increases. D ground increases because now no use of D. Now O count also increases, and still count is 3 only. So size is decreasing. Size will decrease side by side, but it is not less than 6, so that's why we have not decreased. When it will become less than 6, we will decrease it. I will change the starting index also. But see, let's see here. Now see, B is here, so I will move this and let's increase the B count to 0, but still it is not positive, so we will not increase the count. And also now window, you see the window length. 10 minus 4 is 6 plus 1 7. Still not. Now E also -1. When we found again, so we will increase the count. When left pointer increases, we increase the frequency, and when R pointer increases, we decrease the frequency. Now at C. Now see the window length. 10 minus 4 is 6 plus 1 7. Okay, no. 10 minus 5 is 6. Still C also moves out, but our window length is still 6. Now see, when we move ahead of O, at O, our length is 10 minus 6, 4 plus 1 5. So 5 we got, and starting index 6 we got at O. Now at D, when O increases to 0, now at D, when you are starting at D, see the count. L becomes at D we have 0. Still we have count. We have length. See the length, because count is still 3. AB, actually count was not 3. At C we lose the count. We lost the count. So 6 is only the minimum, because at C we will do again. We will do again. Let's do it again. At C, move back to C again. Move back to C. Move back to C. Move back to C. Move back to C. We will see what happens at C. When we came at C, here we came at C. So what happened? Now the window length is 10 minus 5 plus 1 6 only. Now when we moved ahead of C, our C count increases to 1. That means count increases to 2. It is invalid. Move the R. Move R. Put N. Still not. We do not got C. Move R. Now we got C. Again greater than 0, so it will count increase to 3. Now see the minimum length. Now see the length of window. So we were at 6. 12 minus 6 6 plus 1 7. No, it is not minimum. Now update the L pointer. Update the L pointer. When we move at D, our O increases to 0, and count is still 3, and see the window size 12 minus 7 is 5 plus 1 6 only, so we will not update. Now when we move at 8, when we move e at e, count of d increases to 0, and window size is 6 minus 8. 6 minus 8 is 12 minus 8 is 4. 4 plus 1 5, so minimum length is 5. Now see, we will update the minimum length because count is 3 only, and we'll choose the starting index to be 8 because see L is here. Now still count is 3. Still count is 3. Wait a minute. Yeah. No. It is something bad happening. 1 minute. I will refresh it. So what happened? We were at E. So starting index become 8, and also let me reduce the weight, and also minimum index become 12 minus 4 8 for 5 5 because 12 minus 8 plus 1. Okay, now C count is still 3. So we'll move update the L, and at E you become it become, because now it is outside the window, so we'll increase the count to 0. Now we are at B. 12 minus 9, window size, C window size, it becomes 4, and starting index become 9. Now see, now if we will again, because count is still 3, when we will again the L, so count reduced to 2. Why? Because B count increases to 1. Okay, B increases to 1, so count reduced to 2. Now see, it is invalid window, so when we will move R, it is break the while loop, and our answer is 9. Starting is 9 and minimum length is 4. So what is the substring? Sub str function. In sub str, I will write it carefully. Oh wait a minute, I will write it in a good writing. Sub str 9 comma 9 comma minimum length is 4. So 1 2 3 4, we will print B, A and C, and this is the answer. I hope you understand the dry run. Let's code it. Okay, so let's code it. Yeah, see, int I equals to 0, int L equals to 0, R equals to 0. Okay, these are the pointers. Now while R is less than h dot size. Okay, also initialize the map 256 to 0, and for int k equals to 0 to k less than t dot size, initialize the map with the characters of t. Let's initialize the map with t of k plus plus. Okay, now start the while loop. When we found a character by R, using R, we'll just decrement it, no matter what, just decrement it. But before that, find out that if the hash of s of r is greater than 0 or not. If it is greater than 0, what we have to do? Count plus plus and then decrement it. Then no matter what, decrement it. Just decrement it. S of r. Just decrement it. While if count is equals to t dot size, what we have to do in this case? And we have to update the r always. If count equals to 3, we have to shrink the window. How to shrink? By increasing left pointer. But also we have to check many things. What we have to check? Suppose if minimum len is greater than j comma j minus r minus l plus 1. So what we have to update? Min len equals to r minus l plus 1. Also starting index also will be updated to l. So, and count, what happened to count? Then we will shrink our hash will increase. First of all, hash of SL will increase because we have increased the left pointer. And also if we have increased and I think also we have to decrease the count. We were decreasing count when suppose B, we have found the B, we were on the left, we were on the B and we were moving L. So we have to, because B is moving out now, B is moving out of the window, so count will be decreased and B will be increased to 1. Hash of B will be increased to 1 and count will decrease to just decrease to 1 place. So suppose if hash of SL was 0, we are decreasing the count by 1, and then we will increasing the hash of L, then we will updating the L pointer. So I think this should return the answer if I'm right. What is count plus plus? He is saying, it is saying count equals to 0 initially. Let's check again. Let's submit it. And boom, it is accepted. So I hope you enjoyed the solution. It was a difficult question, hard question. Okay, let's meet in the next video. Till then, goodbye.